Carbon fiber as a material, it's kind of an open book as far as what you can do with it. Carbon fiber, quite frankly, just has far fewer limitations. There's a lot more molding techniques that you can use to implement different shaping. On our mountain bike frames, we use carbon fiber to actually act as a spring or a measure of compliance. Carbon fiber is also great for strength, where we need very high strength applications like fork steerer tubes and things like that. With carbon fiber, we can really build a bike that is much stronger and certainly stiffer and more rugged than what we could out of a metal alloy. You could manufacture the bike to be stiff in one direction and compliant in another. You can design things like integrated leaf springs and full suspension bikes, and you can have bikes made exceptionally stiff and aerodynamic, like our Olympic track frames. With carbon fiber manufacturing, we can blend the material to get the layup and the structure design to add compliance in certain areas, and then beef up the areas where you want that stiffness, the bottom bracket, the pedaling stiffness, the head tube stiffness for accurate and precise control and handling. So at Felt Bicycles, we've developed our own sort of blend of carbon fiber that's used in different scales of manufacturing. We call that our Ultra Hybrid Composite, or UHC blend of carbon fiber. For the most part, the UHC performance is what you're going to find in a few of the other industry leaders in carbon fiber manufacturing. This is a blend of intermediate and high modulus carbon fibers. We use the intermediate fibers where the strength requirements are quite high, those impact requirements, and we use the higher modulus carbon fiber to improve the stiffness. These are bikes that are capable of racing and winning at the highest levels of sport and cycling. We also have a blend of carbon fiber, our UHC Advanced. This is where we get into a little bit more exotic frame materials. Some higher 40-ton and 60-ton carbon fiber materials are used here. Blends from different carbon fibers from aerospace and motorsport industries. This is a much more expensive process as far as fabrication goes. There's generally more pieces, more individual patches and patterns for each carbon fiber layup, and it's a more specific or controlled environment for manufacturing. The UHC Ultimate, that's a recipe that almost changes year to year or as advancements are uncovered. Most recently, we're using the Textream carbon fibers in our UHC Ultimate blends. And UHC Ultimate goes right alongside our FRD approach of creating the very best. So those things are kind of all constantly in flux as we learn more and more about different materials that become available, and we learn how to best optimize and use them in bicycle frame manufacturing. The Textream 76 material is a 76-gram sheet of 1 square meter, so it's fiber area weight of 76 grams per square meter. Typically in bicycle manufacturing, we use sheets with 100 grams per square meter or even 200 grams per square meter, and that's in a unidirectional fabric where all of the fibers run in the same direction. You also get improvement with Textream in the actual fabric itself, with each of those individual strands being flat, consistent, with no gaps in between. You can reduce the resin content as well, which further enhances the low weight and high strength properties. Our frame molding process was originally started with internal bladders, and those are specially shaped, really balloons, more rigid than a latex balloon, but basically a bladder on the inside that gets pumped full of compressed air, and that provides some internal pressure. The outside mold is then clamped to the outside of the frame, and then the whole assembly is put into an oven where heat cures the resin between each layer of carbon fiber, and the bladder on the inside helps to compress those layers together. Now, with our inside-out molding technology, we no longer use air pressure in an air bladder. We use a very specifically molded polyurethane or expanded polystyrene mold. Those molds are exactly shaped to the net internal shape of the bicycle frame. Everything from the front derailleur mount, bottom bracket cable guides, everything is molded internally as well as an external mold. So there's no chance for any waste, for any material to get wrinkled, or any excess resin to build up. We can also be much more specific with each individual piece. Carbon fiber bicycles are made up of hundreds of sheets and individual pieces of carbon fiber, and you generally have to overlap those pieces. They don't fit together like a jigsaw puzzle. The layers overlap, and with inside-out molding technology, we can get much closer to that jigsaw puzzle type fit because there's less movement of the material during the molding process. What that's allowed us to do is to get frame weights from where they were, even 10 years ago, where 1,100 to 1,200 grams is a pretty reasonable weight for a carbon frame. Now we're under 700 grams. Those frames are stiffer and stronger than what they were just a short generation ago. We can very carefully control the amount of resin in each joint. We can very carefully control the wall thickness and the amount of compaction that each one of those layers of carbon fiber uses when we use this EPS molding technique. It's exceptionally painstakingly long to manufacture products this way, but it's an extra step that we take to further our advancement.